So let's start. Welcome back. And the next presentation relates to how hybrid mobile applications work, attack surfaces and weaknesses. Please welcome Dave Hartley from MWR.
So I've only given this talk once before. It was in Cape Town. I had an hour, which was better than today, but I was hungover, so it was more of a struggle. Today I'm sober and I've only got half an hour, so maybe it won't make much difference, but we'll see. Okay, so hybrid mobile apps. Who am I? Dave Hartley, I work for MWR Labs. I do CREST and testing and things. What's the point? So we're going to discuss today hybrid applications. Now it's a complex ecosystem of different types of apps, but I just want to get a few distinctions out of the way to start off with. Native apps are apps coded in what they call the native language for the platform. So if it's Android, it's Java. If it's iOS, it's Objective-C. If it's Windows Phone, it's C#. It's pretty simple. Web apps are web apps are web apps. You all know what web apps are. Hybrid is a mashup of the two. Typically, that's going to be a mashup of the native language that's being used, the managed code, or including some web components. There are variances on that I'll go into later, but the most popular hybrid apps are the web mashups. Typically, they are, well, back in the day when they first started out, they looked pretty ugly and horrible, and they looked like a web page, and that was it. Now, there's a lot of styling gone into it, a lot of HTML5 techniques, functions, features. The CSS frameworks that come with them can pretty much make the apps look like a native app. So on face value, when looking at them, sometimes it would be hard to tell the difference between an iOS app and an Android app, say, that was written with managed code native for the device as opposed to a hybrid app. There are some nuances, differences, performance things, but in most cases now, most of the frameworks will make it look and feel exactly like a normal application. So from a sort of model view of them, you've got your managed code running on the device that has access to native features, and then you have an application container that runs within specifically a device web browser, which is typically a web view, or later instances, like a Windows Phone instance of Internet Explorer. The purpose of the containerization is to... I could have moved. What are you going to do now? It's basically to give access to device features. Obviously, if it was just a HTML, JavaScript type app, it wouldn't have direct access to the camera, to contacts, to things that are only available to native apps. So you need a native component that can do all that, and a way for the web component to get access to that. And that's typically through some sort of bridging, or at least some sort of serialization and deserialization comms channel. So a little bit of history of why I got into this was it kind of came off a side project. I was looking at ad networks embedded into applications, and the technology and the features they were using led to how these hybrid apps work. But also I had some clients coming to me and saying basically they wanted to look at using hybrid apps instead of having, say, 3 development teams developing 3 different native applications. And on the face of it, it starts to make a little bit of sense. So some of the pros that are batted around about why you would use a hybrid app, some of middle management, some penny pinchers, etc., start to get excited. So apparently you don't need to know Objective-C, Java, or C# to build one of these. You need web dev skills, and they're cheaper than mobile guys because there's more of them, easy to find. Reduce dev time and support, i.e. it's quicker to write in HTML and JavaScript than it is to write in Objective-C or Android. I'm not saying I believe in any of these, but these are the ones that get batted around, and these are the ones that are given as reasons when discussing this approach. Reduce security testing costs. Obviously, this grabbed my eye when this one was put across. If they're developing 3 native apps, you're testing 3 native apps, surely if they're writing 1 hybrid app that runs on all platforms, that's reduced their cost by that factor. It's easier to update and push updates to. If you just got a web container and all your code's in HTML and JavaScript, then there's no need for that to go through any sort of app approval process or again, additional reviews. So as now, if you've got a native app, you might have to wait another month or 2 before you can push a patch in and an update. then that's gone in these situations, or advertised as gone. Cons, slower than native applications. So this is getting a little bit different with some of the optimizations that have come out with various different sort of web instances and browser instances, Chrome and stuff. There's competitions now to see who can get the fastest JavaScript rendering engine and going and stuff. So they are getting faster, but they are still noticeably slower than a native application, in my opinion. Again, the styling is good. It's getting there. It's not perfect. If you look at a lot of the different forums that produce these frameworks and some of the complaints, you know, stuff between switching between landscape and portrait, trying some of the fancier features and stuff, they just don't work or they look clunky. Source code visible, again, these aren't mine, these are what you'll find if you look around into this. I'd argue that an Android application source code is as visible as HTML. And Objective-C, yes, you've got a little bit more to go, but C# no, so not quite a valid argument. So this one I do kind of stand by. Web devs don't necessarily know the intricacies of the hybrid framework. So this is one of the points of the talk, and we'll get into a lot about this. I don't think when these were battered around by some of the sources I got them from, they actually meant security, but security is a big player in this. Security considerations, well, the hybrid stack itself is quite complex on how it works, and I only started to realize this the more I scratched into it and looked. You get a lot of people that advertise that if you give them your app, they'll churn out another app that runs on another platform. And the magic that happens in between is very black box, and you've got to do a lot of digging to find out. PhoneGap's a lot easier to dig into because it's mainly open source, but a lot of the other solutions aren't, and you've really got to figure out what's happening there. And it's got HTML, JavaScript, HTML5, CSS, then obviously all the stuff that's going on under the hood that's managed and native. So it is quite complex, and there's a lot of different tiers there to bolt together, and a lot of different security models and nuances across the different platforms. The security of native apps, so we still test a lot of Android and iOS apps and find a lot of problems, common problems, over and over and over again. And we still test a lot of web apps and find the same problems over and over again. Neither of those disciplines have been solved. And now what we're doing is mashing it in together and thinking it's going to be fine. So what are these hybrid frameworks? Where can you get them? So the most popular is PhoneGap. It's free and open source. It was bought by Adobe and then rebranded to something else, but both are still running in parallel. And it is the most popular. There's some research come out that said others are taking it over, but for me it's the one I see the most often. And we'll sort of cover that in today because I had to sort of cut out some of the other stuff. MoSync, that's another free and open source thing. They call their technology Wormhole, the actual implementation of this sort of translation layer. Accelerator Titanium, that's a really interesting one. You can do an entire talk or two just on the way that one works and the attack surface for that. They've got something called crawl microkernel that exposes bindings for Python, Ruby, and does a whole bunch of serialization and deserialization of messages from the web layer. So that's an interesting one. But it's not as popular. It's also one that tends to get used a lot in these magic box scenarios. And there's a lot more, but once you start digging into them and find out a little bit more, they tend to be just extra layers on top of PhoneGap, or they support PhoneGap APIs with tweaks here and there. So you end up finding out you're looking at something you've already looked at before. So it's not worth looking at them if they're not that popular and not in use by people that we know. There's just a quick grab from some of the App Store. Grab them down, have a look. It's easy to find out they're running that. But also these are advertised on some of these black box providers that say we'll convert your app into a hybrid app that runs on everything. And they have these listed as their clients. So big name brands are using them for a lot of things that perhaps you wouldn't necessarily think you should do. How does it all work? So you get your SDK from PhoneGap or wherever for your hybrid framework. In that, you get an IDE or you plug it into your existing IDE. You code out your HTML, your HTML5, your JavaScript, whatever. Piece all that together, and behind the scenes, this magic happens. When you bolt it all together and run it through the compiler, it implements this little bridge. And this bridge goes from the web layer straight through into whatever managed code is running on the device to give it access to native functions. And that's as simple as it gets. Magic happens at compile time that implements this little messaging layer that when you run the application allows access from the web layer to the managed code layer and the native features. So what does it look like under the hood? I'll not spend too long on here because I don't have a lot of time. The reason for the next series of slides is just to show you at a code level what the implementation of these bridges look like. Take some of the magic away because it really isn't that magic. So here is in Object-C how you would implement one of these bridges. And what we're doing here is just trapping a event, basically a web page load. So you see window.location at the bottom that loads a URI. That URI is, and this is where I always screw up because this has got a, so you get a scheme, you can name a method, param one. Basically this is just a URI, and as long as you conform to the URI scheme, you can smuggle whatever you want through. Because this function here will track that request, inspect it, parse it, and you basically just pull out bits and pieces and action them as you would. So you could have here a class, method, parameters, whatever you wanted. You define another function, class, method, whatever, somewhere else, parse it in here, depending on the value that you extract, then call it with those parameters. So you've smuggled that through from the web layer. Android's a bit more complex because they like to give you a lot of choice. So you get different methods. This one is should override URL loading, works in exactly the same way as the iOS version, traps the web request. Android JavaScript interface, we'll cover a bit on that later, but I think everyone knows what's wrong with that, and if not, we'll just skate over it a bit later on. But basically this works in slightly a different way to the trapping a request. This actually exposes an object in the DOM of the web page within the web view or the container that's presenting it, and that means that you can call that object, any methods that are exposed or bound to it from the web interface. So there it's basically creating a JavaScript object called bridge. When you inspect the DOM, you'll see an object called bridge. It'll stand out because you can't use introspection on it to enumerate what's exposed. And basically, on any of the sort of hybrid apps, you might see a prototype library or something like that. It'll have defined bridge dot object and then passing parameters backwards and forwards. And you just define that in your Java, and it's directly accessible from the web container. Due to bugs and other things and just general hackery with Android, there was a reason why these came about, but basically you can overload certain standard functions that are already exposed to the web layer. So alert, confirm, boxes, things like that. You overload those and smuggle through extra parameters, trap it in your Java code, and then action and parse whatever comes through. Windows Phone has a defined way of doing this. WebScript notify, again, it's just setting up this channel. You call it from JavaScript, external notify, pass whatever you want through there, serialized, deserialized, parse it. The concept, don't concentrate too much on the code, use it for reference if you're auditing these things, but basically the concept is you have something in managed code that either exposes directly the function of the method that you're trying to call, or exposes some way of smuggling data backwards and forwards where it can be inspected and parsed. BlackBerry has the same thing, cascades post message, on message. They have a couple of different ways to do things because they've got a couple of different ways to write applications. This is the standard way of exposing it in Cascades apps. WebWorks, this is massively complex, which is why there's a URI at the bottom to have a look into it. WebWorks is now powered by Cordova, the Adobe purchased branded version, I think, or it might be the other way around, I forget. It's far more complex to extend this. You have to write your own C++ plugins or Qt codes and mess about with extensions and stuff. That URI will walk you through the process, but they've added complexity to the process to do this, which means probably more attack surface and probably more bugs. On the flip side, we talked about going from HTML web layer straight down to the native layer. You can also do that from, you can also from the managed code call out to JavaScript. So there's a lot of applications that will call into JavaScript to execute stuff in the DOM and return results back to managed code. So it's a two-way channel in a lot of cases. So what sort of defenses do they have from a security perspective? Not many. Essentially what it should be doing is trying to have a same origin policy to prevent any nefarious people injecting code and causing undesirable things to happen in the application. But really all they've got is the same origin policy and the OS access control policy, or the permissions that are in there. So everyone kind of knows what SOP is. It basically means that you can't have a foreign object calling into a parent object, and restricts it to protocol, port, domain. Except when you use a lot of these frameworks, same origin policy just gets blown away. In the add JavaScript interface example that I showed, adding one of those interfaces means it's accessible to all domains everywhere, same origin policy gone completely. You have to kind of re-implement it. So to re-implement it, PhoneGap has this whitelisting approach, AppMobi does. MoSync doesn't bother, it's your fault, deal with it. WebMarmalade same. BlackBerry WebWorks is great, supports really fine-grained domain access control. I can't praise that enough, except they don't use it for PhoneGap. Permissions, this is your normal install time, runtime permissions, on prompt, whatever you want to call it. iOS runtime access control. This is the stuff you're more used to, but those are really the only two security controls they're going to rely on. Same origin policy. If it's broken, they have to re-implement it, and permissioning for the app itself. So the title of the talk was Fracking. This isn't something that I came up with. I stole it from an academic paper, and they've stolen enough from me over the years, so why not? But the paper's actually quite good. It talks about all the different frameworks and different attacks and gives some examples. But essentially, it's the phrase is coined to any sort of attack that drills through these defenses that are in hybrid apps. So what are some of the weaknesses? Well, a native application, we've been through this a ton of times, man in the middle, stuff like that. We've got different SSL libraries that we can use. We can control the ciphers that are used. We can have pinning, etc. All of that's gone when you try and use a hybrid app. There's no by default, method of interacting with these security components of a mobile application. There are certain plugins that can be written and have been made available by third parties, but by default, none of these things are available. So straight away, if you're using HTTPS connections, they can be downgraded, often man in the middle. If you're using, or most of them just default to HTTP anyway. Introspection, you can't use introspection to basically discover any exposed classes and methods. It's kind of a brute force effect, but there are a ton of libraries that get embedded in these apps, and you can man in the middle of those library loads, have a look, reset them up, inject them, and prototype, or you can just go back to roots, and all they're doing, even in the prototypes, is calling and constructing those URIs. So you just figure out the URIs and generate the URI yourself. All of it's in the documentation, so you just go to the docs and find out more. The whitelisting, by default, a lot of them are to Slack or aren't applied. There's been many published bypasses for them, and these are just the default ones. When a client actually gets these, if they haven't been left in the default state, they still fail miserably when rolling them. The other thing is, these generally apply to the whole container. So if legitimately you start wanting to embed adverts or third-party tracking or whatever from other sites, you can't if you use whitelisting. So you've got a choice. You have a very flat, controlled app with whitelisting, or you open up to everybody. Some of the methods used to do the content inspection are flawed. So should override URL loading, should intercept request, etc. These are the things that they implement the whitelisting. So when they track the request, they'll check the origin of that call and see if it's an allowed domain or not. Some of those methods don't trap all calls. So depending on which method's implemented, you can make calls without them ever being inspected. Same on iOS, should start load with request. It can't trap script sources. So the first thing you're going to do is inject your own malicious script, load it from a third party, and if they're using should start load with request, it'll never be inspected or trapped. Some more XML, HTTP requests, iframes, etc. The difference is there's no perfect one to use. So some of them layer them together and do multiples, and there's different ways around that as well. But when you're inspecting these apps and looking for them, it's really important to figure out what method they're using, if they're using any whitelisting whatsoever, and then you can look at different vectors for injecting your own code to start manipulating these apps. This is an interesting one. I've actually come across this a couple of times now. People create a custom protocol handler to inspect all requests. Now this is a lot better at being able to trap all of the different types of request events that can be made. However, I've seen some implementations that then rely on looking at specific client-side controls within the requests, which can obviously be manipulated to bypass those. So in this example, I think this was an app that was doing it for caching and adding a header to basically say, I've already processed this, don't reprocess it. It's been checked to make sure it's legit, or it's not been checked. So you just add basically a header that says, I'm all good, let me through, and it does. That's the one anyway. I skipped ahead. It's not too bad because I've got a lot more slides to go through. On Windows 7 and 8, it installs a handler for the browser navigation. Again, it doesn't trigger for iframes or XML HTTPs. Origin checks, the add JavaScript interface method, and the prompts. Some of them don't have the ability to inspect the origin of the caller at all. So that information is just not available from them. And what I've seen is implementations that try and do this when the application's using these techniques and they think everything's good. They're doing the check, but they're not getting a proper value back. So the check's null and void, and it always passes whatever through. BlackBerry, this is the really good one. Very, very granular. You can set domains, subdomains, individual permissions, individual objects, methods. All the features can be very granularly controlled. So if you developed an actual application yourself on BlackBerry using these techniques, you could fully leverage the security model, and it would be very effective. But if you do it with a PhoneGap app, they don't use this. They just throw it out the window, so you lose all that security that's there. A lot of the PhoneGap applications have the ability to use all the different techniques that we sort of talked about, the interface, the trap requests, etc. And depending on the device that it's running on and the version of the API that it's built against, because not all versions support all different types of interfaces, it will make a dynamic runtime decision on which sort of bridge it's going to use. The ability to switch between those bridges is available as a client-side control. So you can use JavaScript to tell it to switch to using a different technique. So if you're trying to attack the application and the bridge technique it's using isn't working for you, it doesn't expose what you want it to, and you can't get past it, you can switch to another bridge that's weaker, which is kind of why I sort of ran through. I know it was a bit fast, all the different ones. Each one has a different weakness, and in a different situation, you may find it's easier to exploit that weakness, and you just have to switch through. And again, that's exposed directly within the DOM of any page that you inject into. Does everyone know about add JavaScript interface code exec? I can't imagine that no one does. So this is one that keeps cropping up again on these hybrid apps because, again, historically it's always been there. And again, if it's not exposed and they're using one of the other methods and it's a PhoneGap app that allows you to switch, just switch over and you can then get code exec on the right device, the right API. This gets interesting and a bit complicated when you're sort of messing about it with it, is frame confusion. If you've got lots of childs all reporting back to your parent or parent to child, depending on where that message originates, you'd expect that the origin of it would be tracked and a reference to it kept. Sometimes it is, sometimes it isn't. It depends on the structure of the DOM, and it also depends on the bridging method that's used, the API that the application is coded for, or the platform it's running on. And you can get these things where basically from a child you can send a message to the parent and it looks like it's from the parent. which allows you a bit more when you're messing about with some of the finer grained controls that are in there. So, yeah, I already said that. 5 minutes racing through. I'm on time. So the bidirectional comms. So I've seen a lot of applications that are set up to allow this parent and child messaging system up. A lot of them are using like JQuery, Ajax, lots of different sort of hipster web libraries. And they're doing it to remote sites, and they're also doing it within frames to keep track of various bits and pieces. You see a lot of, you know, the parent frame will be waiting for a message from the child frame before doing something, or doing it asynchronously. There are ways, so when they've put in these defense layers, again, it's not by default. I've seen developers then try and add extra defenses to track where these messages are coming from and what they should action and what they shouldn't action on. And some of them have been set in cookies. Again, the web developers, they're familiar with cookies, so they think a cookie is going to be the right way to go about it. A lot of the times you can mess about with these, so you can steal the cookie from a parent or a child domain which it's been passed to and reuse it for access across. This is the one. I forget which slide this is in. That's the one I just covered. In jQuery itself, you find a lot of outdated libraries. They obviously don't bother upgrading these things. They don't think anything could go wrong with them. This is just a few examples of some of the different types of cross-site scripting. There are protection measures in there, attacks that work against some of the evasions, and there's been more and more and more cropping up. And if you follow, yeah, jQuery ticket 11617, that's a really interesting thread to read through, because you've got a bunch of guys talking about a bunch of different attacks and the different evasion techniques they're using to get around a lot of the controls that are being put in place. And there's at least one or two developers that have basically just come back and said, the very design of what you're trying to do here is flawed. You can't rely on a JavaScript framework to implement security controls to protect itself from JavaScript attacks. So these continue to be a problem no matter what framework is in use. The developer that's using these features to pass messages backwards and forwards between these parent and child relationships, 9 times out of 10 you're going to find some way of injecting your own code into there to affect the parent DOM and get access to one of these native bridges somehow. It's not an easy hunt. It relies on you looking at a lot of messed up JavaScript, injecting your own sort of debuggers and things like that, and it's by no means an easy task. But once you do find that vector, the whole application falls apart. So the purpose I originally sort of put this together was because when I was looking at the ad networks and the techniques in there, it was the right pain in the ass to do a lot of things. So I wanted to document an assessment approach and some of the tool sets and the approach that I take for others to be able to pick it up and fast track some of the elements. So basically, it's pretty standard. You're going to have to be able to man in the middle of the comms and inspect everything that happens. And that just doesn't mean in your normal web. If you're testing normal web apps, all these remote loads of web libraries and frameworks and things that get pulled down, a lot of the times are generally ignored because it's not what you're testing. It's actually pretty important in these hybrid apps to have a look at some of those libraries because they set up a lot of prototyping for communicating with the exposed methods and the bridges, and understanding how all of that works behind the scenes is quite useful. So number one thing is just to man in the middle of all those loads, figure out if the remote loads that you can grab or whether the local loads from local resources embedded in the app, and just study it and figure out what is exposed and what the prototypes look like. This is a pain on iOS. It's a bit easier. On Android apps, it's a bit more of a pain. But basically, yeah, you have to roll some sort of ghetto, asynchronous bit of JavaScript that you can basically serve from a web page and call eval on and start to inspect the DOM, or you're going to always be re-injecting new scripts, etc., or getting reloads. You want something that's pretty interactive to speed things up. There are a bunch of different debugger frameworks out there that you can get. Some of them work, some of them don't, some of them need too much effort, some of them depend on the version of Chrome or WebView that's in use. I still always end up going back to something pretty basic in Ghetto. Custom bridge objects, you're going to have to walk through the entire DOM looking for stuff if you haven't already found those from the documentation or the frameworks that you've had a look at. typically the named juicy things. PhoneGap ones are all default, they're all in the documentation. Same thing for other frameworks, you'll be able to find it out. Or what sets off red flags as well, or objects that you can't introspect over. The prototypes and the COM channels, if they're HTTP, HTTPS, it can't overstate how much time you will save by being able to steal someone else's prototypes rather than having to go back to the application, decompile it, reverse engineer it, whatever you call it, find out what they should look like, and then reconstruct them from that view. Default functionality in PhoneGap, they expose pretty much everything: file system access, ability to make requests, access to contacts, SMS. It's all there by default. You have to manually turn it on. Go on then. You want me off? Reverse the app, have a bit of luck, stuff, reverse the code, look for defenses, tokens, regex. Once you've sort of gone through everything else and everything you've tried injecting isn't working, the defenses may well be custom, but 9 times out of 10 you're going to get around them. You just have to go back to old school sort of native application inspections. So wrapping up, there's a varied and exposed attack surface with all the containers, the web, the native stuff. The devs are bolting different technologies together, and what you can actually achieve differs from platform to platform. And that's something important to understand. When we go back to these pros that were listed up, so you don't need to know Objective-C, Java, C#. Well, if you don't understand the weaknesses that are going to be exploited in your application. You need to know all those languages to review the apps as well, because each device it runs on has a different attack surface, regardless of whether it's hybrid or not. Reduce dev time and support? Well, no, you're still writing for 3 different platforms or 4 different platforms. It doesn't just magically work the same way across them all. And reduce security testing costs actually increases, because now you need to test it on all 3 platforms, but you also need to test all the web components, which takes a lot longer. So you've increased costs.